Dear students, in continuation to the different types of antennas which are studied in the previous sessions, like horn, helical antenna, parabolic, then log periodic, aguda. So in this session we are going to discuss about reflector antennas. What is reflector antenna? Then what are its different types and where it is used? Dear students, reflector antenna tells you that the antenna which reflects the electromagnetic waves. So by reflecting the electromagnetic waves again and again, what happens? The efficiency of the radiation increases and also directivity increases. And this reflector antennas has different shapes. So one is the plane shape, another is the corner shape, third is the curved reflectors. So these are the different geometrical configurations of the reflector antenna. You already studied the curved reflectors in the previous session, that is paraboloid. So parabolic antenna or dish antenna is which consisting of the reflector, which is the curved surface of the parabola, and what is the distance between the focal length and the locus point, as well as the directrix, distance between directrix and this one locus point, and all these things you would studied in the parabolic antenna. So here we will see once again the parabolic reflector along with plane and the corner type of an antenna. So before that, let us see the applications of the reflector antenna. Reflector antenna used in the radar, radio detection and ranging, which can be used in satellite communication. In satellite tracking also we are using this reflector antenna. In the radio astronomy we are using this, and other microwave communications also we are using this reflector antenna. This is existing as an stand-alone device for redirecting the RF energy, radio frequency energy, in order to improve the performance of the antenna. Let us see different shapes of the reflector antenna one by one. One is the flat sheet reflector antenna. Here I am showing the picture representation of the flat sheet reflector antenna for various sizes. One is large flat sheet, second is small flat sheet reflector antenna, and third one you are observing the thin linear reflector element. Another is the linear antenna driven element, which is shown in the figure C. The reflector element is separated from the driven element by the distance d, is also shown in the figure C. So look here, flat sheet near linear dipole antenna is to reduce the backward radiation. With small spacing between the antenna and the sheet reflector yields substantial gain in the forward directions. Next type of the reflector antenna is corner type reflector antenna. You are observing the different views and also the reflector antenna at various angles. And here you are observing the reflector antenna at alpha is equal to 90 degrees. So the reflector is used as a passive target for radar or communication applications. It will return the signal exactly in the same direction. So when the signal return exactly in the same direction means the angle which is included is 90 degrees. To maintain the given system efficiency, the spacing between the vertex and the feed element must increase as the included angle of the reflector decreases, and vice versa. So next you are observing the reflectors with the infinite sides, the gain increases as the included angle between the planes increases. Bandwidth is high, when the feed elements are cylindrical or biconical dipoles instead of thin wires. The perceptive view and wire grid arrangement for the corner reflector antenna also shown in the figure C and D. So look, this is the parabolic reflector antenna which already studied in the dish antenna or parabolic dish. So this parabolic reflector antenna, which consisting of the parabolic reflector, which is the curved surface of the parabola. So this what are the applications of this reflector antenna? Reflector antenna can be used in the satellite communication systems to enhance the gain of the antennas, and also which increases the directivity of the antenna. And the parabola, what is studied is the curve traced by the reflector on any plane which is normal to the aperture plane and containing the focus. Thank you for watching this video.